All right, good morning and welcome back. Today we are going to be just doing a little bit of a review of what we have covered so far. So basically what we covered in quarter 3. I'm going to touch on 2 problems from both chapter 4 and chapter 5. Just watch along. As long as you watch it all the way through, you'll get the points. Just make sure you don't skip ahead or it'll tell me what percentage of it you watched. You won't get full credit if you skip ahead. So watch it through. I'll try to keep it brief, but this first question is from our review of chapter 4. And this was a question where it said, a jet is sighted in the sky between 2 people on the ground who are 7 miles apart. Okay, so we know these 2 people are 7 miles apart. Now it tells us they report their angles of elevation to be 75 degrees and 25 degrees. Angle of elevation, remember, means from the person up to what they're looking at. Okay, because let me show, I guess, a better angle of elevation is above horizontal like that. Okay, so that one is going to be 75 degrees. And from the other side, it is 25 degrees. Now, our end job is to decide how high is the jet. Now, it doesn't tell us this, but I'm going to make it dotted because we have to deal with the solid triangle first. Okay, how high is this jet? Now, that's a right angle because the height and they are on the ground. So height is perpendicular to the ground, which is the horizontal. Okay, so now the first thing we can do, we need to figure out what that missing angle is right up here. If we know what that whole angle is, then we can do some stuff to figure out what our height is. So first thing, we know all the angles on a triangle add up to 180. We have 25 and 75, so let's add that together. We get 100. Take that from 180. And oops, that was supposed to be a minus, but minus 100 equals 80. So 80 degrees is what goes right up here. Now, the reason that is important is now we can use what is known as our law of sines. Remember, law of sines, in order to use law of sines, we have to have a matching pair, but the angle on the opposite side. So I have this 80 and the 7. I can do sine of 80 divided by that 7 equals, now you could do either one, either sine of 25, then you'd find this side, or sine of 75, then you'd find this side. It does not matter. I'm going to solve for this right here, so I'll do sine of 25 divided by x. Okay, now at this point, we'll cross multiply, we'll solve for x. Keep in mind, you have to make sure your computer or your calculator is in degree mode. Okay, so now we are going to cross multiply. If we cross multiply, we'll do 7 times sine of 25. And then whatever we get, we will divide by the sine of 80. And as you can see, we get 3.00, so we'll just say 3.0 miles. And we're not done. That is what this x is, so I can put that right here. Now the reason that is important, okay, now that I know that side is 3.0, I can now draw a different triangle. The same triangle for the height there to the person. The reason we care about this triangle, there's a right angle there. Okay, now I know there's a 75 degree right here. I know we just found out this is 3.0. This is what I'm trying to find out, is the height. So we can use SOHCAHTOA now to help us solve because we have a right triangle. So this would be our opposite side. This would be our hypotenuse, which O and H, SOHCAHTOA is sine. Okay, so we'll do sine of 75 divided by 1 equals opposite, which is x, over hypotenuse, which is 3. At this point, we just cross multiply. So we will do 3 times that sine of 75. And we, oops, I did that wrong. 3 times the sine of 75, close the parenthesis, hit enter. And as you can see, we get 2.89. So if we round to the nearest tenth, 2.9 miles. That would be our total height above the ground for that jet. All right. A second problem we did in chapter 4. It says, name the quadrant where both the cotangent of theta is greater than 0 and the cosecant of theta is less than 0. So keep in mind, cotangent pairs with tangent, so both of those will be the same. And where's the tangent? Greater than 0 means positive. Meanwhile, cosecant pairs with sine. Sine less than 0, so sine negative. Now, in case you forgot, we remember have our 4 quadrants, and we know that both in the top right, everything's positive. Sine, cosine, tangent, all of those are positive, so that's not our situation. If we go to the left, cosine, which represents our x, becomes negative. But sine stays positive, but tangent also will be negative because one of each. Remember, to find tangent, we do sine divided by cosine. Down here, we will have both a negative sine and a negative cosine. If we divide a negative by a negative, we will get positive. And at that point, I hope you can see this is our answer. So quadrant 1, 2, 3, that's our answer. But just to finish it out, over here, sine is still negative. Cosine is positive. Tangent, since there's one of each, will be negative. So that was chapter 4. We did several other things in there, but that was kind of just a few things that really stuck out to me. Okay, so now let's go ahead and look chapter 5. So to do this problem, cosecant pi over 3, in order to solve for that one, we have to use our unit circles. So cosecant, if you'll remember, pairs up with sine, so it's the reciprocal of sine. So sine is our y, so it's going to be 1 over y. Now, if we look at our unit circle, the y value at pi over 3 right here is square root of 3 over 2. Since it's cosecant and not sine, we're going to do the reciprocal. So we'll do 2 over the square root of 3. Okay. Now, cosine is our x. We look at 3 pi over 2. 3 pi over 2 down here. The x value is 0. So plus 0. Now, if we add those, we'll get 2 over the square root of 3. We'd be done, except can't leave a square root on the bottom, so we times by square root of 3 over square root of 3. At this point, we get 2 square root of 3 over 3. And that would be our final answer. Now, the second thing I want to talk about from chapter 5 is we had to graph sine, cosine functions. So we're going to graph this cosine. Remember the pattern to graph cosine: 1, 0, -1, 0, and 1. Now, the first thing we need to do is decide what's our amplitude, what's our period, is there a phase shift, and is there a vertical shift. So the amplitude right at the front, there's a 3. That's very easy, I hope. To find the period, remember it's 2 pi divided by b. In this case, b right here, the 4. 2 pi over 4, so our period is pi over 2. Phase shift does not happen. There's no parentheses. Vertical shift is down 2, or you can put -2. Now, before we can graph, remember we also need to find what our interval is. Take whatever your period is and divide it by 4. And remember, dividing by 4 is the same as multiplying by the reciprocal, so 1/4. We would get pi over 8. That is my interval. Okay, so right there, that is my interval. Okay, so at this point, we are ready to start graphing. So let me switch to black here. We draw, and we know it's down 2. And so that is the midline right here. We know the midline will be at -2. And then the amplitude is 3, so it'll be up. Oops, let me do that in black again. To -1, 0, and then all the way up to 1. It will also be down -3, -4, -5 will be the bottom. Okay. Now we know there's 1, 2, 3, 4 marks. That first one, pi over 8. It's always whatever the interval is. If we'd add pi over 8 again, we'd get pi over 4, because we'd have 2 pi over 8. Then we have 3 pi over 8, and finally we get 4 pi over 8, which reduces to pi over 2. And remember, that should match our period, which right here it does. So we did it right. Okay, almost done. Now we just got to graph with our pattern. So our pattern for cosine, 1, 0, -1, 0, 1. So 1 means 1 amplitude above the midline. Midline's -2, the amplitude's 3, so up here, 1 amplitude above. 0 means on the midline, -1, 1 amplitude below. 0 is on the midline, and 1 is 1 amplitude above. And we kind of curl that in. And we are done. So I hope you guys have a great break, and let me know if you have any questions. Send me an email, and I'll talk to you in April.